Hi, class. This is my second attempt to record a video lecture. Still working with some new technologies to try to figure things out, but should be more or less worked out soon. If you guys have any suggestions or comments, let me know. But I'm just going to try a couple different software approaches and then see how they look. So basically for this video, I'm just going to go over the animation lesson that we were going to do last week on Thursday, March the 12th, right after the Corona hiatus was first announced. So for that one, instead of using the meme that we've been working on, I'm actually going to start from scratch. I think that'll be a good chance if you haven't been using your home computer or whatever your device you're using now as your setup. I'll just kind of like go over some of the setup stuff. I'm on a Mac now. I do have a Windows, so if you want me to do some stuff on Windows, or if you have trouble with a Windows machine, I can let you know what to do with that. So yeah, I hope everyone is doing well. I'm sure that you have a lot to do in terms of catching up with what all of your different professors are doing with their classes. If there's anything I can do to make things easier, let me know, shoot me an email or message me on Blackboard. I'm going to keep everything on Blackboard, so there'll be announcements for everything. We'll make discussion threads. I think that'll make things a little bit more straightforward. And I think these video tutorials will be the best way for me to give you guys the lectures. I think the disadvantage of this obviously is if something doesn't make sense, you can't raise your hand and ask me to go over it again. But you can, pause the video and go back over something, or if you're stuck somewhere, you can always email me and I'll try to work out a solution with you. We can do a screen share or something like that if we need to really debug something or troubleshoot something. So anyway, I covered a lot of stuff in that email that I sent. So if you have any questions about that, let me know. I've heard back from most of you guys, so thank you for that. If you did not respond to my email and we haven't had any communication at all since the break, please send me an email and just let me know that you are aware that we're going to be doing these video lectures and etc. and using stuff on Blackboard. Anyway, I'm going to get started with this this tutorial or lecture or whatever you want to call it. I'm going to get rid of this camera. Just wanted to say hi, but I don't think it's necessary to have it on the whole time. You'll still hear my voice. And I'm going to try using some different stuff. Like I have a little screen annotation thing that I'll use today. Most of what you see will look like what we've seen before, so I'm just going to use the class site. I'm going to use Sublime Text and GitHub Desktop. So everything that you'll see should look relatively familiar, even though I'm on a Mac rather than a PC. But if you have any questions or want me to go over anything, I'm happy to do that. So anyway, I'm going to close this window and I'm just going to start with the lesson. So I changed the schedule. I haven't updated everything yet, but you'll see that the physical computing section is gone. We're just kind of stopped right here at week 7 animation. We're going to finish that up right now. And next week I'll start posting the new schedule that we'll use going forward. So last week we did cover the animation lesson. And so what I'm going to do is just do the transformation lesson with a new meme project. So I'm going to do some stuff from scratch just so I can kind of go over things. If you haven't been working at home, this will be a good chance for you to follow along and do everything that to get started. Go to week 7 animation and click on transformation. And so we'll have the notes here. I'm going to be adding some of this stuff into a new demonstration. And so I want to make sure I'm up to date with everything. So I'm going to get my GitHub desktop. Okay, so if you don't have that on your computer, you need to go and download it. There's a link in the main page for the class. So that would be if you go to MM210 and you scroll down a bit under the software section, you can see links for all the different software we use. So there's the brackets text editor, which we haven't been using. Sublime text editor, the browser Chrome, which I prefer, and then the GitHub desktop app. So if you don't have it on your computer, you can go ahead and download it from there. So I'm gonna open that up. So I can go to the Spotlight, which I can access with the little magnifying glass in the upper right-hand corner on the Mac. I can also do Command Space, and then I'll type in GitHub Desktop. However you want to open it is fine. If you're not signed in, this is what you'll see. If you are signed in, you should see, some of your folders or something like that. I'm not signed in yet on GitHub Desktop, so I'm just going to click sign in to github.com. I'm going to type in my username and password. And if that all worked, then I should see something like this where I can either clone one of my repos or create a new repo or add something. And I can also see the repositories that I have online. So there's my ON BMCC MM210 repo, which is what I want to work on. So I click the clone button. You will see this local path thing come up. We've gone over this in class, but just to go over it again. It's okay if you have this folder inside your documents folder, but I like to have it visible. So usually what I'll do is I'll click here and just choose desktop and click open. And I'm going to say, okay, so depending on what operating system you have, you might get something like this. Just click OK. I just upgraded to Catalina, so I have to give all of my programs access to the desktop, which is a little annoying, but that's okay. So then in the local path, what you'll see is desktop and then MM210. So that's how I can get it to show up here on the desktop. It doesn't have to be there, but that will probably be the easiest setup. So I'm going to click clone here. And there it is. My folder is now on the desktop. So there's a couple of things I can do. So it's already figured out that my main editor is Sublime Text. I can also look at it in the Finder. So if I click Show in Finder, it's going to open this window. Your Finder may look different than mine. If I have some of the kind of settings turned off, but usually what I like to do is have this view open where I'll show you what this looks like. You probably have something like this if you're on a Mac. I usually like to use this third option right here. You can change the options by doing Command 1, Command 2, Command 3, Command 4. I like Command 3. It's just easier to see all your files. So you can see I have the desktop here, MM210. I have my index page here, and then all my folders. So that's an easy setup. So that's usually how it'll look, but it doesn't have to look like that. So I like to kind of take these things out, but you can do whatever you want. Okay, so we can get it in the Finder. In GitHub, we can also open it in Sublime Text, which is a nice little shortcut to getting our text editor open. If it doesn't see that you have Sublime Text there, you can open up Sublime. And, actually you can't see this in the top of the screen, but I'm clicking on File. Let me actually stop and make it so you can see everything on here. I had a little error when I was trying to start the Sublime server, and what I did is I restarted my computer. So if you do see an error like that, just go ahead and restart your computer and hopefully it'll be fixed. If it doesn't, then just let me know and we'll come up with another way to do this. But anyway, what you want to do is you've got the Sublime server installed, go to Start Sublime Server, okay? And then go back to Chrome or your browser, and you want to go to the localhost 8080. Okay, so we did that in class. It's in the class notes under week 5. You can just type it in as well, and I recommend bookmarking that. So just type in localhost :8080, and there should be the Sublime server. I'm zoomed in for some reason, so I'm just going to zoom out. Command 0. And then click on MM210, and here we go. here's our landing page. So if I click on meme version 4, I'm not going to get anything there because I haven't built that yet. So let's just go back to the landing page. Let's create our project, and then we'll get started. So I'm going to go back over to the Finder. And I don't have my window open, so I could either look for it on the desktop, or since I know GitHub is here, I can just go to repository and show in Finder. So that's a good way to find the repo. And so I'm going to start a new project from scratch. So I'm going to make a new folder. On the Mac, I can do Command-Shift-N. I can also do File, new folder, Command-Shift-N. And whoops, you do not want that to be inside another project. Let's put it in the main folder. So I'm going to name this meme_4 because that's what we created a link for. Oops, wrong one. Okay, undo meme_4. And so I want to use a lot of the same stuff I had in meme3. So I'm just going to copy all this. And so I'll just grab all that stuff and hit copy and then paste it into here. So Command-C and then Command-V, or you can go to edit, copy and edit paste. And then I'm just going to delete the sketch.js. I'm going to start that from scratch. So let's take a look at those files real quick, and then we'll get into adding the animation. So I'm going to go back over to Sublime, and I'm going to close out this page, which is the landing page for my MM210 website. So I'm going to X that out. And so now I have this meme4. So some of the stuff is the images I made in class, the cat image, there's the dog image, and there's our panther image. The style.css is, what I've been using all semester. I'm not going to change this. The index.html, okay, that's says meme version 2, which shows me that I forgot to update my meme version 3, so I can do that later. But let's just update this now, meme version 4. But everything else on here looks fine. I have this font that I added on Google Fonts. I have the header for my meme. I have a link here. I have the P5 and I have the sketch.js. So I deleted the other sketch.js, so that's not going to work at this point, but we're going to create a new one and add that in there. I have my P5 library. I'm not going to open that because I don't need to, but you can see it's right there. And so now I'm going to get started. So I'm just going to create a new file. So I did Command-N, or you can do File, New File. And this I'm going to save as. So I'm going to do Command-S, or you can do File, Save As. And this is going to be my sketch.js. So I'm starting this from scratch. So sketch.js. Okay, so now we have that in there. And of course, I'm always going to start with a comment. So I'm going to do a multi-line comment, /*, followed by asterisk and then / to close it. And I'm going to indent over. And I'm just going to say this is my meme version 4. Doing some transformation plus animation. And the date today is March 18th, 2020. Okay, so let's get started. So I'm just going to start from scratch. So, we're doing a P5 sketch. So we always start with our setup function. So just some function setup, parentheses, and then curly brackets. And we're going to create a canvas. So I'm just going to do the same canvas I usually do, create canvas. Oops, misspelled that. And I'll do, I guess for the meme I was doing a square canvas. So for this one, I'll keep with that. So I'll say, I think I did 500 by 500. I don't know why I'm doing a square canvas for this. I guess because when you see memes, usually it's on Instagram and those images are usually square. But that looks fine. We'll just create our canvas and then we'll go to our draw function. So we're going to do function draw, and that's where all of our drawing is going to happen. Gonna add some stuff in here. Eventually we'll add our images and we'll do some more stuff with that. For now, I'm just gonna do a background just so we know it's working. So I'll just do a black background. I'll put a 0 in there. And so we should see a black background. And once I've got that going, I'm just gonna go back to my transformation lesson. So now let's reload our page and go to meme version 4. And there's our blank canvas with the black background. So that's where we're gonna put this new meme. And so I'm gonna open up the console just to have that ready. And right now I've got it not docked inside of Chrome, but I can change that if I just go to this menu over here and click on the dock to right, and that'll put it right there. And I'm just gonna put on the console tab. It's pretty small on here, so I'll just increase that a little bit, just make it a little more visible. So now I'm ready to start. So let's take a look at some of the concepts we're going to cover for transformation, and then we will keep going. So I'm going to go back to the MM210 website, go back to schedule, go back to week 7. So we did the animation lesson already. We're doing the transformation lesson now. And once I'm done with this, I'll go over the assignment again. So I'm going to click on transformation. I guess I'll use the slides view just since we have it. So we're going to be talking about transformation. And this topic is a little bit different than what we've done previously in the class. It uses a lot of the same stuff like variables and numbers, but we're actually going to be moving the entire canvas around. So it's going to be a little bit different. The way that works, let me open. Okay, so the way that works, okay, so the way that it works is we first have to remember that our canvas always starts at 0, 0. So if we look at the canvas we've got in our meme example over here, before we change anything, the origin is always at 0, 0 right here. I can use my little screen drawing tool to draw, circle right there. Okay, so that's the origin. Okay, so if we're moving on the X direction, we go this way. If we're moving on the Y direction, we go that way. And so all the drawing that we do has that sort of as our basis. What we can do with our transformations is we can move that point. So I can take this point and I can move it to the center of the canvas or wherever else I want, and then I can use that as a way to do animation. So I'll try to show some different examples of that, but let's go ahead and look at some of the examples on the class notes. Okay, so translate is how we move the origin. So there's a link here to the documentation in P5. You can see some examples here, but we're gonna make our own examples. So basically with the translate function, we can translate the X and the Y. We can also translate the Z if we were working in 3D, but we're not gonna do that for today. So what we can do is we can just move the origin to a new point in the canvas. Here's a little interactive example. You can see the code here, translate X, Y, and then I'm gonna change the value of X and Y using these sliders. And we'll see the rectangle, even though the 10, 10 and the 100, 100 don't change, if I translate, okay, those values change. So 0, 0 moves and everything else moves along with it. So let's look at an example of that. So in my own code, if I draw a rectangle, I'm going to draw a rectangle at 0, 0, and I'm going to make it 100 pixels wide and 100 pixels tall. So I'm going to save that and then open up my meme. And there's my rectangle. Okay, so 0, 0 matches right here. So if I want to move that rectangle, let's say I want to move it just down to here, to the middle of the canvas, what I can do is translate. So one way I could do that is I could change the position of the rectangle. I could move the rectangle to 250, which is half the width, and 250, which is half the height, and there's our rectangle. But I can also leave those 0, 0 there, and I can translate the whole canvas. So I can translate, I'm going to do width over 2, so half the width, height divided by 2, half the height, and now our rectangle is moved. The translations work just like our fill or our stroke in that it only applies to things that come afterwards. So if I take a rectangle here and put it in the top, now I'm going to have two rectangles. Okay, so the same rectangle, 0, 0, 100, 100, 0x, 0y, 100 width, 100 height. Same rectangle, but we translate in between. So this 0, 0 moves down to here. And so that actually is not that exciting by itself, but it's going to allow us to do some pretty cool stuff with animation once we get down a couple more examples. So I'm going to leave this translate here. I'm going to remove this rectangle. And let's go back to the notes. Okay, so here's a little example in the notes where you see, again, it's the same ellipse. So ellipse at 0, 0, ellipse at 0, 0, ellipse at 0, 0. Same ellipse, but it's in 3 different places. So we can see how translate works. We also can see that translate is additive. So that's something I should go over real quick. So the translate is additive or cumulative, meaning that it adds up. So if I have translate width over 2, height over 2, and there's my rectangle, and then I translate again, okay? And so let's say I'm just gonna do like 20 and 20. So you might think that, I'm gonna copy this rectangle and throw it down here. So you might think that this translate would just go to 2020, so that it's sort of like, you know, up here in the top left somewhere, like 20x and 20y, somewhere up here. But actually what we'll see is that it's just a little bit further from width over 2, height over 2. So once we do this first translation, width over 2, height over 2, so we move down here, the second translation, even though it's just 2020, we're starting from that point and then we move down here, so it's cumulative. So let's keep going with that. I'm going to delete this. Because we're actually going to see a way that we can undo that later, but for now we're just going to do that. Okay, so let's start actually making a cool animation. We're going to use the rotate function. And so the rotate function, it rotates the entire canvas. So we'll look at how that works. Here's an example, an interactive example in the notes. So again, you see we're translating by X and Y. Okay, so that right now is 2020, which is that blue dot right there. And then we're rotating, it's starting at 0. So it looks normal, there's no rotation at all. And we have a rectangle at 0, 0 and 50 pixels by 50 pixels. We have the ellipse at 100, 100, which is somewhere there, and the 40 pixel diameter. So if I rotate, we're gonna see we rotate around the origin point. So our shapes are rotating. If I move the origin point, our shapes still rotate around that origin point. So that's one way that we can create an animation, by changing that value. So let's add some rotation into our example. So after I translate, and I'm going to show why this is important in a second. So let's just rotate by, let's say half pi. So remember, pi is our constant that is used to measure the rotation of a circle. So if I go back here, so now we're rotated half pi. So we've rotated around really a quarter of a circle. Basically, we've rotated around like that. So that's half pi. So remember, full pi is 1/2 rotation. And at full rotation, all the way around, is 2 pi. And so we can use that as basically a way of knowing how far to go if we want a specific rotation. But pi is really just a number. If I put it over here in the console, we can see that pi is 3.14, half pi is just half that, and 2 pi is twice that. So they're really just numbers, but they're convenient ways for us to see an exact rotation. So let's do actually quarter pi, so it looks more rotated. Okay, so there we see it's a quarter rotation around the origin. Now look what happens when I take out translate. So I'm going to remove translate. And so now we see we're back at the origin and we've rotated around the origin point. But what if we had our rectangle at width over 2, height over 2? Okay, so if I say width over 2 instead of 0, height over 2 instead of y, now see our rotation happens at a much wider angle. And so we'll see that again when we make it animated. But that's part of why we want to translate, is so that we can rotate around a specific point. So I'm going to actually leave that for a second and then we'll update it. So I'm going to go back to the class notes. Here's some examples of rotations. Okay, so in each case we're drawing the same thing. You can see that the rectangle at 0, 0, ellipse at 100, 100. Rectangle at 0, 0, ellipse at 100, 100, and the same thing down here. So each one of these drawings is the same, but we can see we're also rotating. So first we translate to the middle of the screen, and then I'm rotating by quarter pi, and then drawing each thing. So that rotation you can see is right there. And notice the rectangle is at 0, 0, so it's rotating around that origin point. The ellipse is 100 pixels out this way on the x-axis, so it's rotating around a sort of wider margin. We also have scale. Okay, so same thing here. Scale by default is 1. That's what we're used to seeing. We can scale down, so it gets smaller, and we can scale up. And we can see that it scales into our origin point as well. So if I move the origin point that way and down there, the origin point always stays in the same place, whereas everything else moves away from it. So if we have our origin all the way at the top, when I scale out, everything moves down and to the right. Versus if I translate down here, everything moves up and to the left. So just like our rotation, our scale transformation is relative to the origin point on the canvas. So if I have it right in the middle, then we're going to scale right into the middle of that drawing. So we can use scale. We can do an animation of that in a bit. So here's just an example of scale. Again, we see the same drawing: ellipse, rectangle, ellipse, rectangle, ellipse, rectangle. They all have the same parameters, but we're starting regular and then scaling to 2 and scaling to 3. So you can see that's cumulative as well. Okay, shear is a bit more tricky to use. So I'll show a couple examples of this and we'll do an animation of it later. But basically, shear is a little bit like in Illustrator or Photoshop if you've used a distort function or what else do they call it? Skew. Sometimes it's called skew. So shear, what it looks like is it's sort of skewing or distorting the canvas. So you can see this here. And what's actually happening is that you're rotating around just like you do with rotate, but some of the points are staying in place and the other points are moving. So in shear X, on the x-axis, you can see that the horizontal lines stay flat. And what's actually happening is that we're pushing our x points away from the origin, this x and this x over here. And the effect of that is that we get an angle on the y-axis. So when we shear x, what we actually see is distortion on the vertical axis. And so that changes if we move away. Even though we've moved away from the origin, the amount that we're distorted stays the same. And so if we move up or down, if we move up and down, we move on that angle. Left and right, we're still just in a straight line. So shear is a bit confusing, but you can get some kind of cool effects where I can kind of warp this image, I can shift it right and left. And so it's a little hard to know exactly how to manipulate it, but it can do some kind of cool things. So we'll take a look at that in animation in a bit. Shear Y is basically the same thing on the other axis. So if I shear Y value, I'm shifting. Okay, so now the Y axis stays flat. The vertical lines are still straight, whereas our horizontal lines get shifted down a bit. So these points over here and here are shifted down because they're away from the origin. So as I shear Y, as I increase the angle there, the angle of my horizontal lines becomes more skewed. And then I can see the animation if I move up and down versus moving up and down that way. So this is actually right and left, but I'm just at an angle versus up and down. So shear X and shear Y, tricky to use, but kind of fun. So here's an example where I'm making it interactive, and you can see the shear X is S1, which is mouse X, and I'm mapping that to half pi. So a quarter of a circle. Down here I have shear Y, which is S2, and that's mouse Y, and half pi as well. So when I look at that, so if I'm up here in the top left corner, both of my circles are totally normal. If I start to go down, then the shear Y increases on that front circle until I'm completely horizontal there. And if I go across on the X, the shear X moves until we're completely, actually that's horizontal, this is vertical. Okay, gotta remember which one is which. And so you can kind of create some cool effects there if I'm using shear X and shear Y on those two circles. We are at push and pop. So as we talked about before, transformations are accumulate as they go. But if we wanted to have different transformations happening at different time, we can use push and pop. So here's links to push and pop in the P5 reference. And basically what that means is if we think of 0, 0 being our first transformation, when we make a new transformation, we can kind of add that to our stack of transformations, and then we can take it off later. Here's an example first where you can see I have these two rotations having around two different points. And this is only possible because I'm using push and pop in this example. So let's look at this. So let's imagine that 0, 0 is our original canvas. Okay, so let me turn on. Okay, so here is 0, 0. And when I translate, I'm moving that origin. So when I translate up here, I'm moving that origin. But what I could do is use push. And so when I say push, I'm kind of making like a stack where I push this 0, 0. And then I'm doing translate. So the second part of my stack is right here. And that when I translate down here, so now 0, 0 is down here. Or that should be a comma, not a thing. So then when I pop right here, oh yeah, I can. Okay, so what that does is it gets rid of this guy and it goes back to 0, 0. So that way I can have my first translation and then do some stuff and then go back to my original translation. So it's a little confusing, but we'll see a couple examples of it. So here's one where those rectangles, you would think maybe they were drawn second, but actually they're drawn first. You can see the rectangle here, rectangle here, rectangle here, rectangle here. Those are those rectangles. So we push, translate to the middle of the canvas, and then pop, so we go back to the origin, and then I'm drawing those circles, which you can see here, here, here. Okay, so now we're getting into the fun stuff, animating with transformation. So we can use our transformation along with some of the basic variables and math that we did before to create an animation. So here I'm using variable R to change the rotation, and I'm setting it to the frame count. So let's take a look at that. Okay, our guy is going real slow. So let's add this to our example and then we can speed it up. So let's rotate. Instead of rotating by quarter pi, I'm going to take this out. I'm going to create a variable R. Okay, so I'm going to say variable R is equal to, and I don't actually really need to use a variable here. I could just write this directly into the parentheses in the rotate function, But just to make it very clear, I'm starting with just creating a variable. And so I'm going to use the frame count. And remember, the frame count is just a number that's just counting up. So when we first run the sketch, it's 0, and each time the sketch refreshes, the frame count increases. So I'm going to do frame count, but the frame count itself is going to go very fast. So we're going to make it smaller in a second. But what I'm going to do is frame count times pi. Basically it doesn't really make a big difference, but it basically just means that we're going to be using pi as kind of a relative measure of our angle. So right now, remember, we left our rectangle at width over 2, height over 2, and we're going to see what this rotation looks like. So I'm going to take this r and put it into my rotate function. And translate is commented out, so it's not happening right now. So keep that in mind. So let's go back, and it's actually just like flashing because that's way, way, way too fast. So let's make it a bit smaller. So I'm going to take this number and I'm just going to divide it by 10. So that'll make it, that's still way too fast. So let's divide it by 100. Okay, that's more reasonable. But now you can kind of see the issue that I'm having here without translating. Because the translation point is still up here, right here, the rectangle is starting here. And so when it rotates, it's rotating around like that, which is why half the time it's actually invisible. It's rotating around part of the canvas that isn't being rendered. And then it kind of shows up back here again. So what we want to do is move our pivot point to here so that we can rotate around that instead of around that. That's why we want to use translation in conjunction with rotation. So now I'm just going to do translate width over 2, height over 2, and I got to remember to put my rectangle back to 0 and 0. X is 0, Y is 0. And so now we're getting that nice rotation around the middle of our canvas. Okay, so I can speed that rotation up or slow it down if I change this number here. That way, basically the frame count is always going up, so that means the rotation is always going up. But as we know, rotation goes around, so it looks like it's just going around and around. And so if we want to change that value, if I divide by like 1,000, it's going to be way, way too slow. But if I divide by like 50, that'll be faster. So however we do it there is good. Let's go back to 100. So the amount it changes per frame is what this R value is. And we can take a look at R if we want. So I can console.log R. And I have the console open over here so we can see that number. And that's just the rotation number that's just going up and up and up. And it's not a huge number because we're measuring in pi. So you might be thinking in 360 degrees for a circle. But actually, since we're measuring in pi, we don't have to use 360 degrees. So the rotation is actually, a full rotation is 2 pi, which is like 6.28 something something. So that's why we see those numbers for R. So let's keep going. Let's maybe add in like an image or some text or something so we can continue working on our meme. So that was the first part of our animation. Let's see, what else do we have to do? Oh yeah, I'm using Shear X here. So let's turn this rectangle into some text, and then we'll add some other stuff to kind of finish out this part of our meme. So I'm going to take out this rectangle. I'm going to use text. So we're still sticking with the text and image for our meme assignment. So I'm going to use some text. I'm just going to say MM210 kind of as a placeholder. And I'm just going to use 0, 0 as the X and Y value for my text. So if I go back to Chrome and go to meme version 4 and I reload, oh, we don't see any text. You might have figured out why. But the problem is because the fill is default to black. So we need to change our fill. So let's do a fill is plum. It's a nice color. And so now we see our MM210 and we're rotating around 0, 0. So there's a couple things we might want to change about that. We might want to make our text a bit bigger. So let's do that first. Text size is, let's say, 50. Okay, that looks better. We could change our font as we did in the past. So our text font, can't remember the name of the font that we downloaded. Let's see, Trade Winds. Okay, so let's put that in there. So I need quotation marks because it's just a font value that P5 is going to send to get from CSS. Okay, so there we've got our new font. And I kind of want to center this. So what I can do is change the text align. So I'll say text align, and I'll say center. That's going to center it on the left and right. Okay, so now it's in the middle, but it's not centered because it usually draws from the bottom up. So we can add comma center here into text align. So that'll be for the top and bottom. Okay, so now we've got that going in the middle. That looks good. I can actually increase the size a bit. Let's try 80. That looks nice. And so that's our rotate. So we can try other stuff. Like if I want to see what is shear X or shear Y looks like, they're still measured in rotation. So I can leave that line the same and just try shear X here. Okay, so that's kind of cool. What about shear Y? Also good. And let's say I wanted to do both. Right? So this is where we can use push and pop. So I'm going to leave all my text styling the same here. And then I'm just going to draw text MM210 00 again. Okay, so since they're drawing exactly the same, we won't see the difference yet. But if I wanted to shear Y1 and shear X the other, I could put shear X here. But now they're both going to be doing it. So it looks a little bit different, but it's not exactly what I'm going for. So this is where I could use push and pop. So I could start with my push here before my shear Y, and then I could pop after my first text. And so then this rotation, or shear Y, will get popped out, so it won't be happening anymore. And our new shear X will just be happening by itself. Oh, but our text align... Huh. Okay, so I guess our text does not survive this pop section. What if I put this up here at the top? There we go. Okay, so our text also got pushed and popped. I didn't know that that was something that would happen, but since it does, let's just put it up here, and let's move our transformations down here. So now our text styling is a little bit not in the same place as our actual text, but at least it's still here. So I'm just going to put a comment. This is the MM210 text styles, in case I use some other text styles later. And this is our first transformation. I guess that's pretty obvious. I'll just say transformation. So then we're just using this variable R to get the angle. Okay, and then we push, do our shear, do our text, do our pop, and then we do a new shear and a new text. So we have two different animations happening at the same time. They're also happening at the same rate. If that's something I wanted to change, I could make two different variables, R1 and R2, or I could just, put this directly into where R is here. Okay, so at this point, we've got some text going. You're probably saying we need to add an image as well, and can we do these transformations with the image as well? Well, we can do it with anything on the canvas, so that also will work. So let's load in one of our images, and then that will be enough for this demo, I think. So let's load an image. We have like a bunch of images over here. I'll just use this cat image. So remember, I need to go up into the top of my program, up into the global scope here, and just add a reference to the cat image. So I'm going to say variable cat image. And I don't assign that to anything at first because right now I can't preload yet. I need to use the preload function. So I need my cat image variable to be global so I can use it in preload and draw. So I'm going to declare that first. Then I'm going to make my new preload function. So remember, preload is just for loading any external assets like images or sounds. And so we'll take cat image, and that is going to be assigned to the value that comes out of load image. So we're just going to do load image. That takes a image from our computer and it loads all of the pixel data into memory. And so we need quotation marks to get a path to something on the computer. And I'm just going to put cat.jpg because it's in the same folder. And so once we've done all that, let's just draw our cat. So I want the cat to actually be behind the text. So I'm going to draw the cat here. So I'm going to say image, or actually we can do it before we do our rotation since the rotation is associated with this thing. So we're going to say image, cat image. So our image takes the image data and then the X and Y. Since we're translating to the middle of the canvas, I'm just going to use 0, 0. And I'm also just going to set the image mode to center. So that'll be an easier way to center the image so that I don't have to worry about calculating the position. Okay, so that looks fine. We've got our image. We've got a little space on the top and the bottom of the canvas. So maybe I want to increase the size of the image just a bit. I can change the width of the image. So we go image value, X value, Y value, and then we can do the width. So the width of the image is obviously bigger than the height of the image. I could do some math to figure it out, but let's just try. We'll start at 600 and go from there. So that looks the same. Let's try 700. Still looks the same. Try 1000. Okay, that's actually not changing the height. It's just kind of distorting it. What if I do 2000? This seems weird. Yeah, that just seems to be distorting it. So that's not really working. So what I could do is just make my canvas smaller. Maybe I'll just do that. Okay, maybe like 380. Okay, there we go. That looks a little better. So, you know, I could make it smaller, but I'm going to stick with that. So now I want to do an animation with the image. I'm going to kind of try to recreate the animation I did with the other image where I changed the size. So we can go home and take a look at that one real quick in number 3. So we kind of zoomed in on the image by changing the image size. But now I'll do the same thing. Instead, I'm going to use scale. So I'm going to create a new variable, S for scale, and I'll set that to, well actually, okay, I'm going to do this a little bit differently. So I can't use frame count because scale does not go in a circle. So actually I need to put variable S up into my global scope. So I'm going to say S, and I'm just going to start it at 1. So the scale starts at 1. And I'm just going to say scale for cat image. So the default scale is 1, so we want to start there. So then I'm going to say scale is S. Okay, so we start, looks the same. So now we can do animation with our scale just like we did with the size. So I can just increase S. So I can say S plus equals. If I say 1, it's going to get really big really fast, and that's not going to be good. It kind of looks cool, actually, but it's a little too fast. We don't know what's going on. So let's just do it by a small number. I can do 0.1. Okay, that's still pretty fast. I could try 0.01. So just using smaller numbers so it scales at a slower rate. So that looks pretty good. I'm pretty happy with that. I don't want my text to scale though. I just want the image to scale. So then we need to use another push pop. So what I would do is push before the scale and then pop after I draw my cat image. Okay, so that'll leave the text the same but animate our image. Okay, so that looks good. So then we can do the thing where we kind of zoom back down. So once we hit a certain point, let's say 2. So I'll say if S is greater than 2, then we want to scale in the other direction. So then I need a speed variable. Okay, so we talked about this last week, just covering it again. So if I want to reverse this, I can't just like say change this number up here. I have to use a variable here. So I'm going to take my 0.01 and make that a variable, and I'll say speed. So this is the speed of the scale, 0.01. whoops. Okay, so I'll say s plus equals speed, and then if s is greater than 2, then I'll take speed and I'll reverse it. So anytime I want to reverse a number, I just multiply and then equals -1. Okay, so remember if I say 5 times -1, I get -5. And so if I have 0.01 times -1 gives me -0.01. So I'll reverse speed, and so then I'll go in the opposite direction. So the scale starts at 1. Once we get up past 2, that's probably big enough, so we'll scale back down. So let's take a look at that again. So we're scaling, and then we go back down. So now we need to, at a certain point, make sure that we don't reverse all the way to now where we're upside down. So that's actually something that I didn't mention, is that you can, if you do a negative scale, you kind of invert everything. So again, that might be kind of cool, but if we want to prevent that from happening, we can add a new condition here. So if s is greater than 2 or 2 lines, s is less than 1, then we'll reverse again. So negative speed times -1 gives us a positive speed, so we reverse again. So this is the same style of animation, but now we're using a translation instead of the image size. So just to point out that basically no matter what we're doing with animation, we're always going to end up using a variable and a rate. So the number that is, the variable is going to represent either the position or the rotation or the scale or the speed, the size. And then we have the rate of animation, which we can call the speed or whatever. And so we can always take that rate of animation and do kind of tests to see if we've gotten past a certain point or too low and change our value there. So I think that's it for meme version 4. So we have a few different examples. I'm going to make sure to update everything. So I'm going to go to GitHub. And once I post this video, instead of putting everything on the public pad, just since we're going to have this video content now, I'll just put links on the YouTube video itself as well as in the Blackboard page. So that way you won't have to go to the class site just to see it. So I'm going to go to GitHub and update this. And you won't, I'm not going to add the link to the public pad, but just look in either the Blackboard post or the YouTube video. You will see, I'll add the links there. So I'm going to say I added or adds meme 4 with transformation and commit to master. And then I'm going to push to origin. Okay, so we're almost done. This is definitely running a bit longer than I anticipated, but that's okay. I'll try to do shorter versions in the future as I get more comfortable in this new format. So let's talk about the assignment for 1 second and then I'll be done. So I'm going to go over to the outline and go to the week 7. And so here's the assignment. I'll add it in Blackboard as well as if I haven't already. So I want you to add animation to your logo or your meme design. You can choose which type of animation you want to use. So you can do the type of animation we did last week using size, position, or color. Or you can do something using translate, rotate, shear, or scale. If you want extra credit, I don't remember how much I put for that, but you can see in the rubric, you can combine in animation using both of these categories. I added some inspiration here. Since we're not going to be in class, I figured I'll try to share more stuff. So these are a little silly, but they're kind of fun. And they're not obviously things you would normally do with P5, but if you want to try to figure out how could I do something like this, you could give it a try. And we could go over ways that you might achieve something like this as well. So those are some inspiration, some logos. We're working on memes, but you could do either one. And so yeah, that's it for now. If you have any questions, please, I'll make a Blackboard thread for this video so you can add your questions there. If you have any comments or you want to see other possibilities, I can also add some more code examples. And if you have any issues of things that you're working on, you can also add that to the thread or just email me directly. So we're still at the beginning of this process of figuring out how to do the distance learning with this class. But I have a lot of confidence that we'll be able to learn everything that we were planning on learning originally. And we'll work with some new tools. We'll use Blackboard a lot more. And hopefully, we'll all be pretty comfortable with that in the next few weeks. But just let me know if you're having any issues with any technology or any other circumstances that are preventing you from doing work, and I'll try to accommodate whatever things you are experiencing. So yeah, that is it for this video. Hopefully it won't take me too long to edit this. I will post it on YouTube, and then I'll share it with you guys, and then we'll go from there. Okay.